Okay, in the previous video, we looked at an introduction to imaginary numbers when solving simple or quadratic equations. Here, I just want to elaborate on what real numbers are versus imaginary versus complex, which is what we're going to be solving our quadratic equations over, is the set of complex numbers. So real numbers is numbers basically that you know about already, that you've used in everyday life. They can be found on a number line in one dimension. Numbers include 1, 2, 3. These are all real. 1/2, or apparently 1/4, because I'm writing 1/4. 0.25, 1/3, the square root of 2, pi. Yes, you could find pi on a number line. It'd just be very hard to get it accurate. And remember that this also includes negative numbers. Measuring tapes don't usually have negative numbers on them, but it would include things like -2, -10, 0.5, things like that. Those are real numbers as well, because the negative just denotes a direction. Now, we talked about imaginary numbers in the previous lesson. Imaginary numbers are numbers that are multiplied by the imaginary unit I. So the simplest example is just I, but 5i, 10i, 1/2 I, pi I, all examples of imaginary numbers. We can even throw some negatives in there, and they're still imaginary numbers because they're multiplied by that imaginary unit I. Now moving on to complex numbers. Complex numbers consist of two pieces. They're numbers that can be written in the form a plus bi. Complex numbers have both a real and an imaginary part to them. So for example, 2 minus 7i is a complex number because it has real, the real 2, and the complex or the imaginary -7i. However, complex numbers also consist of numbers like 7. 7 is a complex number, even though it doesn't have an I or isn't in that format, and that's because we can write 7 as 7 plus 0i. Therefore, it will have a real part and an imaginary part. Same thing with -5i. That may be an imaginary number, but it is also complex because we can write it as 0 minus 5i. So complex numbers consist of both the real numbers and the imaginary numbers and the combination of a real and an imaginary number. So any number that you can think of is a complex number. So when we solve solutions for quadratic equations, we'll be finding it over the quadratic or over the complex number system, which includes both real numbers and imaginary numbers and their combination here in Algebra 2. Whew, that was a big. Okay, in this video, we're going to be adding and subtracting complex numbers, or in this case, adding complex numbers. We're asked what is the sum of 2 plus 3i and 5 minus 6i. We're supposed to write the answer in a plus bi form. So we're doing 2 plus 3i here. We're finding the sum, that means addition, with 5 minus 6i. Addition is nice, but just to connect it to something you may have done before, this is very similar to x plus 2 plus 3x minus 4. It's similar to something like this, which you would have done in Algebra 1. We just have imaginary units in this instead of the variables. So once we have that, because it's addition between the parentheses, nothing's connected to the parentheses here by multiplication, and therefore the parentheses aren't actually serving a purpose. So you can either ignore them or just rewrite the problem without the parentheses. And then just combine like terms like you normally would. So 2 plus 5 is 7, and 3i minus 6i is negative 3i. You'll notice normally when we combine like x's and stuff, we'll start with the highest power first, and that's how a lot of people often combine the like terms. However, with the i's, you'll usually put that after, because you usually want to write it in this a plus bi form, where the real number comes first and the imaginary number second. That's it. 7 minus 3i is the answer. In this example, we're asked what is the difference of 2 plus 3i and 5 minus 6i, and we're supposed to write the answer in a plus bi form, which is how you often write it whenever you're dealing with complex numbers. So we have 2 plus 3i, and we're finding the difference, which means to subtract 5 minus 6i. Now, this is a little bit harder than addition and subtraction, or this is subtraction. It's a little bit harder than addition, but it is very similar to what you probably have done before when you did it with x's in Algebra 1. So we're going to do the same idea, and there's a bunch of different ways I can approach this. The way I usually do it is anytime we have a negative in front of a set of parentheses or a minus sign in front of a set of parentheses, I treat it as having a negative 1 there. So it's like having negative 1 times the parentheses 5 minus 6i. And if you have a number in front of parentheses, to get rid of the parentheses, you just distribute it through. The first complex number doesn't have a number connected by multiplication or a number in front. Therefore, we don't need the parentheses. So I'll get rid of them now. But for my negative 1, my minus 1 here, we're going to distribute that through, giving me negative 5 plus 6i. Negative 1 times 5 is negative 5, and negative 1 times negative 6 is positive 6i. After dealing with that, it's just combining like terms, just like addition and subtraction. So 2 minus 5 is negative 3, and 3i and 6i make 9i. And that's it. So in this example, we're asked what is the product of 2 plus 3i and 5 minus 6i? And again, we're supposed to write the answer in a plus bi form. Well, product means multiplication. So to set it up, we're going to take 2 plus 3i. We're going to multiply by, and notice multiplication, it's implied, so we don't need to put any operation between the two sets of parentheses, but we're going to multiply by the complex number 5 minus 6i. Now, multiplication will behave very similarly to x plus 3 times 2x minus 1, but there is a little bit of a difference as you go through it. So when you do this, we will distribute like we did in Algebra 1. 2 times 5 is 10. 2 times negative 6i is negative 12i. 3i times 5 is 15i. And 3i times negative 6i is negative 18i squared. There is one major difference between what we were doing here in Algebra 2 with the complex numbers and what we did in Algebra 1 with the x's. Distributing the x's out gave us 2x squared minus x plus 6x minus 3. But unlike with the i's, x squared didn't actually have a value. I has a value or meaning. Remember that I represents the square root of negative 1. And therefore I squared actually represents negative 1, or is negative 1. So anytime we multiply complex numbers, when we see an I squared or a higher power of I, it can usually be reduced to some simpler format. You can always write operations of complex numbers in this a plus bi form. The way we do it is we go about looking at I squared as just -1. So that last term really isn't negative 18I squared, it's negative 18 times -1. So if I rewrite this, we have 10 minus 12I plus 15I, and then the negative 18 times -1 gives us positive 18. So instead of subtracting 18I squared, it's really adding 18, because I squared is -1. And then after that, we just have to combine like terms. So 10 and 18 make 28, and then -12 plus 15 makes 3I. And there we have it.